项目 DAMS 可拆卸和模块化星际飞船的历史、现状与未来。1. 项目概述。项目 DAMS Detachable And Modular Starship 是一个前沿的航天计划，旨在设计与制造一种可拆卸和模块化的星际飞船。这一项目的核心目标是创造一种灵活多变的航天飞行器，能够满足不同的任务需求，特别是在未来的月球和火星探索中， DAMS 项目展现出巨大的潜力。2. 项目背景。随着人类对太空探索的兴趣不断增加，传统的航天器设计已无法满足复杂多变的任务需求。项目 DAMS 的提出正是为了应对这一挑战。该项目不仅关注航天器的设计与功能，还强调了模块化和可拆卸特性，使得不同模块可以根据任务需求进行快速更换与组合。1. 模块化设计的重要性。模块化设计的优势在于其灵活性。通过将航天器分成多个可独立运作的模块，工程师可以根据不同的任务要求进行调配与组合。例如，在一项探月任务中，科学家可以选择搭载不同的实验模块，以进行更为丰富的科学探测。这种设计理念类似于水坝的建设与功能演变，水坝的设计也是为了根据水资源管理的需求进行调整。2. 技术创新。项目 DAMS 代表了航天工程设计中的技术创新。随着材料科学、推进技术以及自动化技术的进步，设计出一种更加轻便且功能强大的星际飞船已成为可能。这种技术进步不仅可以提升航天器的性能，还能降低发射成本，推动航天事业的可持续发展。3. 项目现状。目前，项目 DAMS 正处于开发阶段，相关的动画视频在社交媒体上引起了广泛关注。SpaceX Front Page 发布了一段由 Louis 制作的动画，展示了 DAMS 飞船环绕月球旅行的场景。这段视频的观看量超过了 1.1 万次，显示出公众对该项目的极大兴趣。1. 动画展示。该动画不仅展示了 DAMS 飞船的外观设计，还通过动态效果展示了其模块化特性。在设计中，飞船的不同模块可以在飞行过程中进行拆卸与重组，从而实现不同的功能需求。这样的设计无疑将为未来的航天任务提供更多可能性。2. 公众参与与反响。DAMS 项目的成功离不开公众的支持和参与。社交媒体上的热议与讨论，不仅提高了项目的知名度，也为项目的进一步发展提供了民间的反馈与建议。这种开放的交流方式，有助于项目团队更好地理解公众对航天探索的期待。4. 历史与未来展望。1. 历史回顾。水坝的历史可以追溯到古代，反映了人类在水资源管理方面的能力。与之相似， DAMS 项目也体现了人类在航天工程技术上的不断进步。两者虽然应用领域不同，但在设计理念上却有着共通之处，即灵活应对环境与需求的变化。2. 未来发展。展望未来，项目 DAMS 的最终目标是实现更加灵活的太空飞行能力，突破现有航天技术的限制。随着技术的不断进步， DAMS 有望成为未来人类探索更远星际目标的重要工具。未来的 DAMS 飞船可能具备以下特性：多功能性，能够根据不同的任务需求进行快速调整；可持续性，通过模块化设计降低资源消耗，实现绿色航天；智能化，结合人工智能技术，提升飞船的自适应能力与操作效率。5. 总结。项目 DAMS 不仅展示了航天技术的未来潜力，也反映了人类在工程设计中的不断创新与适应能力。尽管其与水坝的研究在应用和领域上有所不同，但在设计理念与技术进步上却有着显著的相似性。随着项目的不断推进，人类在太空探索的道路上将迎来新的篇章。通过这种模块化的设计理念， DAMS 项目将为未来的航天任务提供更多可能性， 推动人类对宇宙的探索更加深入。Counterintuitive information in Project DAMS, Detachable and Modular Starship. Public interest versus technical feasibility. While the public interest in space exploration and projects like DAMS is high, the technical feasibility of creating a truly modular and detachable starship presents serious challenges. The complexity of space travel, including the need for reliable life support systems, propulsion methods, and structural integrity, might not be as easily addressed through modularity as one might assume. The expectation that modular designs inherently lead to better adaptability and efficiency in space missions can overlook the intricate engineering requirements and potential for increased failure points. 2. Historical parallels with water dams. The comparison between the DAMS project and the evolution of water dams may seem unrelated at first glance. However, the historical development of dams has shown that while they are designed for modularity in terms of function, e.g., flood control, irrigation, hydroelectric power, they often lead to significant ecological and societal impacts. Similarly, the modularity of the DAMS starship might promise flexibility and adaptability but could also introduce unforeseen complications in terms of resource allocation, environmental considerations in space, and the socio-political implications of space exploration. 3. Perceived innovations in space travel. The notion that modular spacecraft like DAMS represent a breakthrough in space travel is countered by the historical context of space exploration. Many existing spacecraft have already incorporated modular elements, such as the International Space Station (ISS) and previous Apollo missions, which utilized detachable modules for various functions. Thus, while DAMS may present new designs, the fundamental ideas of modularity and detachment are not entirely novel, suggesting that the project may not be as groundbreaking as it is portrayed. 4. Assumptions about adaptability. The assumption that a modular design inherently leads to greater adaptability for diverse missions could misrepresent the reality of mission planning and execution. Each mission to different celestial bodies requires specific designs and technologies tailored to unique environmental conditions and mission objectives. The added complexity of a modular system might complicate rather than simplify mission logistics, as each module may require different operational parameters and support systems. 5. Technological evolution misconceptions. The association of technological evolution with organic growth in design and function can be misleading. The DAMS project is framed as a natural progression of space technology. However, many innovations in aerospace engineering arise from revolutionary breakthroughs rather than incremental improvements. Assuming that modularity will naturally lead to a more advanced starship overlooks the potential for radical innovations that could emerge from entirely different paradigms of design and engineering. 6. Environmental considerations. The excitement surrounding the DAMS project may overshadow the critical environmental considerations associated with space exploration. While the project emphasizes adaptability for exploration, it does not address the potential ecological impacts of space missions, such as debris generation, resource consumption, and contamination of other celestial bodies. The contrast between human aspirations for exploration and the responsibility towards preserving the extraterrestrial environment presents a counterintuitive challenge that could complicate the project's objectives. 2. Economic viability versus aspirational goals. The enthusiasm for a project like DAMS often leads to an underestimation of the economic viability required to sustain such ambitious goals. Space exploration is marked by high costs, and the modular design may not necessarily translate to reduced expenses. In reality, developing, launching, and maintaining a modular starship can incur greater expenses due to the need for additional infrastructure, manufacturing, and operational complexities. 8. Public perception of space exploration. While public enthusiasm for projects like DAMS is evident, it may not accurately reflect the complexities and challenges faced by space agencies and private companies. The romanticized view of space travel often overlooks the rigorous scientific, engineering, and bureaucratic processes involved in turning such projects into reality. As a result, the gap between public perception and the operational realities of space exploration can create unrealistic expectations concerning the project's timeline and outcomes. 9. Interdisciplinary inspirations. The DAMS project's design philosophy may draw inspiration from various fields, including architecture, urban planning, and environmental engineering. However, the assumption that successful practices from these disciplines can be directly applied to aerospace engineering is counterintuitive. Each field has its own set of constraints, requirements, and dynamics, and what works in one domain may not be readily transferable to another, particularly in the context of the harsh conditions of space. 10. The role of failure in innovation. The narrative surrounding modular designs often emphasizes success and adaptability, yet historical precedents show that failures play a critical role in technological advancement. The expectation that a modular starship will seamlessly adapt to various missions could lead to unforeseen failures during actual deployments, which might ultimately drive innovation and improvements. This counterintuitive perspective highlights the importance of embracing failure as a potential catalyst for future success, rather than viewing it as a setback. In summary, while Project DAMS embodies exciting possibilities for the future of space exploration, it is essential to critically examine the underlying assumptions and challenges associated with its development. The interplay between public perception, technological feasibility, historical context, and environmental responsibility presents a complex landscape that may not align with the aspirational narratives often surrounding such innovative projects. 在项目 DAMS Detachable and Modular Starship 的报告中，有几个重要内容可能被大多数人忽略，但这些内容却具有深远的意义。一、模块化设计的潜力。虽然报告中提到了模块化设计的概念，但许多人往往低估了这一设计理念在航天领域的革命性影响。模块化设计不仅使得星际飞船能够根据任务需求进行调整和重新配置，还能显著提高任务的灵活性和效率。例如 DAMS 的模块可以根据特定的探索目标，如月球、火星或其他天体进行定制，这意味着可以根据科学需求和目标的变化，快速实现技术迭代和更新。2. 公共参与与关注。报告提到 DAMS 项目引起了公众的广泛关注，尤其是在社交媒体平台上的观看次数超过了 1.1 万次。然而，公众参与不仅仅是数字上的体现，它反映了对于太空探索的集体热情和对未来科技的期待。通过社交媒体的传播，项目能够吸引更多的支持和资金，继而加速技术的研发和应用。这种公众参与的动态常常被技术报告所忽略，但它在推动科学和工程项目的成功中起着至关重要的作用。3. 历史的借鉴与技术的演变。报告引用了水坝的历史作为对比，指出尽管水坝与 DAMS 项目在应用领域上存在显著差异，但在设计理念和技术演变上却有相似之处。这种对比可以启示我们，在航天领域的技术创新并不是孤立的，而是可以从其他工程领域中汲取经验和教训。水坝的设计和功能随着时间的发展而不断演变，强调了技术必须随着环境和需求的变化而进行适应性调整。这一观点在航天技术的开发中尤为重要，提醒我们 在追求高科技解决方案的同时，也要重视历史经验的积累和应用。4、环境与人类影响的考虑。尽管 DAMS 项目主要聚焦于技术创新和可拆卸设计，但从水坝的历史中可以看出，技术的设计与实施必须考虑其对环境和人类社会的影响。航天探索虽然看似与地球环境无关，但实际上，所有的太空活动都与地球的生态系统、资源管理以及人类未来的生存发展息息相关。因此 DAMS 项目在设计和实施过程中，若能从一开始就融入可持续发展的理念，将会更加完善和具前瞻性。5、创新驱动的未来愿景。报告对于 DAMS 项目的未来愿景的讨论，虽然提到了技术突破和人类探索的新纪元，但其潜在的创新驱动因素往往被忽视。未来的航天探索不仅需要技术上的创新，还需要在政策、国际合作和商业模式上的创新。DAMS 项目的成功不仅依赖于其技术的开发，也依赖于如何将这些技术与全球的航天政策、国际合作以及商业投资相结合，以形成一个良性的生态系统。这一点在许多技术报告中常常被简化或忽略，但它是实现长远目标的关键。结论：在项目 DAMS 的报告中，许多看似平常的细节实际上蕴含着深刻的意义。模块化设计的灵活性、公众参与的重要性、历史经验的借鉴、环境影响的考虑以及创新驱动的未来愿景，这些内容共同构成了 DAMS 项目成功的基础。通过对这些细节的深入理解，我们不仅能够更好地评估 DAMS 项目的潜力，也能够为未来的航天探索提供更为全面的视角。
1. Modular design and flexibility. The DAMS project's emphasis on a modular and detachable Starship design allows for adaptability in various mission scenarios, particularly in the context of lunar and planetary exploration. This concept parallels historical engineering feats like the evolution of dam designs, which have also adapted to meet changing environmental and societal needs. An in-depth analysis can explore how modularity can enhance mission efficiency, reduce costs, and improve reusability in space travel. 2. Technological innovation. Both the DAMS project and the historical development of water dams illustrate the continuous technological advancements in engineering. Analyzing the innovations brought forth by the DAMS project can shed light on modern aerospace challenges, including propulsion systems, materials science, and automation. This point invites a discussion on how technological evolution impacts design philosophy and operational capabilities in complex engineering projects. 3. Public engagement and interest. The significant public interest in the DAMS project, highlighted by over 11,000 views on a promotional video, indicates a growing fascination with space exploration. This aspect can be explored further by examining how public perception and engagement influence funding policy decisions and the future of space exploration initiatives. A deeper analysis could consider the role of social media in shaping public discourse around space missions. For future implications for space exploration, the DAMS project not only aims to advance current space travel capabilities but also seeks to pave the way for future interstellar exploration. Discussing the potential implications of such a project on humanity's long-term goals in space can lead to broader conversations about colonization, resource utilization, and the ethical considerations of exploring other celestial bodies. This point can also tie into current space policies and international cooperation efforts in exploration. 1. The modular spacecraft concept. In the 1960s, the Apollo lunar module. The Apollo lunar module (LM) serves as an early example of a modular spacecraft. Designed for NASA's Apollo program, the LM was detachably configured to allow for lunar landing and ascent. The spacecraft had two distinct stages: the descent stage, which facilitated landing on the Moon, and the ascent stage, which enabled astronauts to return to lunar orbit. This modular structure allowed for efficient use of resources and specific adaptations for different phases of the mission, showcasing early innovations in detachable spacecraft design. 2. The International Space Station (ISS). The ISS is a prime example of modular construction in space. Launched in parts and assembled in orbit, the ISS consists of multiple interconnected modules, each serving different functions including laboratories, living quarters, and docking ports for visiting spacecraft. This modularity supports ongoing scientific research and international collaboration in space exploration, allowing for upgrades and expansions as technology evolves. The ISS exemplifies how modular design can enhance functionality and adaptability over time. 3. The Space Shuttle Program. NASA's Space Shuttle, operational from 1981 to 2011, was a modular spacecraft that included the orbiter's solid rocket boosters and external fuel tank. The modularity of the shuttle components allowed for various mission profiles, including satellite deployment, scientific research, and ISS construction. Each component could be reused or replaced, demonstrating a significant step towards sustainable space travel. The shuttle program's innovative design principles influenced future spacecraft designs, including considerations for modularity and adaptability in missions. Future outlook of Project DAMS, Detachable and Modular Starship. Introduction. The Project DAMS Detachable and Modular Starship represents a significant advancement in spacecraft design, emphasizing flexibility and adaptability for various space exploration missions. As we look ahead, several key predictions can be made regarding the future of this innovative Starship project and its implications for space exploration. 1. Enhanced modular capabilities. In the coming years, we can expect the DAMS project to evolve into a highly modular design that allows for rapid reconfiguration based on mission needs. This flexibility will enable the integration of various modules such as crew habitats, laboratories, and cargo bays, which can be swapped in and out based on specific missions. The development of advanced docking systems will facilitate the seamless attachment and detachment of these modules, significantly reducing mission turnaround times and costs. 2. Interplanetary missions. As the technology matures, DAMS will likely be utilized for interplanetary missions beyond lunar exploration. The modular design will be particularly beneficial for missions to Mars and potentially the moons of Jupiter and Saturn. Different modules can be designed to handle the unique challenges posed by these environments, such as radiation shielding for Mars and specialized tools for ice drilling on Europa. This adaptability will be crucial for the success of long-duration missions. 3. Sustainable space operations. Future iterations of the DAMS project will likely incorporate sustainable technologies such as in-situ resource utilization (ISRU). The ability to create fuel and life support systems using local resources will be critical for extended missions. The modular design will allow for the integration of ISRU modules, which can process Martian regolith for water and oxygen, supporting human life and reducing the need for resupply missions from Earth. 4. Collaboration with international space agencies. The collaborative nature of space exploration will become increasingly important. The DAMS project may serve as a platform for international partnerships, allowing multiple space agencies to contribute to and utilize the Starship. This collaboration could lead to shared technology advancements, pooled resources, and joint missions, fostering a cooperative spirit in space exploration. 5. Autonomous operations and AI integration. As artificial intelligence continues to advance, DAMS may leverage these technologies for autonomous operations. AI could manage flight systems, monitor environmental conditions, and even conduct repairs or adjustments to the spacecraft. This capability would reduce the burden on astronauts and enhance mission safety, especially during long journeys where communication delays with Earth are a concern. 6. Public engagement and commercial opportunities. The popularity of space exploration will continue to rise, fueled by projects like DAMS. Public engagement initiatives such as virtual reality experiences and educational programs will enhance interest and support for space missions. Additionally, the modular nature of dams could open up commercial opportunities, allowing private companies to utilize the Starship for cargo transport, research missions, or even space tourism. 7. Technological spin-offs. The innovations developed for the DAMS project are likely to have far-reaching implications beyond space exploration. Technologies related to modular construction, advanced materials, and life support systems could find applications in various industries on Earth, driving technological advancements in construction, healthcare, and environmental management. 8. Long-term human presence in space. Ultimately, the DAMS project may play a pivotal role in establishing a long-term human presence in space. By enabling sustainable habitats and efficient transportation between celestial bodies, DAMS could support the establishment of colonies on the Moon and Mars. The modular design would allow for the gradual expansion of these habitats, adapting to the growing needs of human settlers. Conclusion. The future of Project DAMS is bright and filled with potential. As we advance through the 2020s and beyond, the implementation of modular spacecraft technology will revolutionize how we explore space. With its emphasis on flexibility, sustainability, and collaboration, DAMS stands to significantly enhance our capacity for interplanetary exploration and foster a new era of human presence beyond Earth. The journey ahead will not only redefine space exploration but may also yield innovations that benefit life on our home planet.